We're ready to start. Okay, so I'm Mike. Mike the Awkward. Sorry for the belabored tech checks. So I work here at BBD Software Development. I work in the research and development team here, and I don't think I could succinctly tell you what we do on a day-to-day basis. We do stuff, but they still pay our salary every month, so I think it's sort of working out. We do a whole bunch of consulting and training and R&D on industry-based things, like my personal research area is progressive web apps, which is what I'm talking to you about tonight. So I am a Google developer expert in web technologies. I'm not entirely certain how that happened. I think basically it's just a merit badge for the sheer number of hours I've spent apologizing for JavaScript's idiosyncrasies. So there's that. But I do care about community, and I care about the web platform and driving the web platform forward. From a community perspective, I'm a co-organizer of Josie.js, which is our monthly JavaScript meetup. Happens on the second last Thursday of every month, or the third Thursday, sometime there the same day. And it's actually happening tomorrow. So if you're available, you should totally come. It's lots of fun. And just to set expectation very, very clearly, I have a little bit of a reputation. And if I had to summarize my entire worldview up with a single image on a single slide with a single word, it would probably be this one. Okay. So you know what you're getting into, okay? Right. So I think it would be irresponsible of me to not at least cover what progressive web apps are, or at least like what my understanding of progressive web apps is. Is anybody that's sort of familiar, has potentially built one before? Okay, cool. Well, don't worry, I'm going to go over it, at least at a high level as to what I think it is. So I'm going to start off by throwing a cheesy acronym at you, right? FIRE, because we can't have a dev talk without cheesy acronyms. And we believe that progressive web apps or modern web experiences are fast both across the wire as well as fast in page with smooth, free scrolling, almost native feeling. That they're deeply integrated to the browser. Browsers are not just portals to information and documents nowadays. They can do stuff, right? I have an identity that's baked into the browser, and I know what the browser is capable of. So we expect our modern web experiences to take that into account. We expect these progressive web apps to be reliable, right? They need to work. They need to work in whichever network conditions we find ourselves in. Getting the dinosaur is not necessarily good enough. And that's a bulk of what this talk is going to be about. And then the last one is that we don't just want documents anymore, documents with images. We want this stuff to be engaging, to have like an app-like UX, things that are above and beyond what we expected the web to do 10 years ago. Okay? Now, those are very high level and airy-fairy, and when we distill it, we see that these progressive web apps all exhibit these characteristics. Okay? And out of these characteristics, they're all really, really valuable, but for tonight, we're just going to care about a subset of them, right? Now, the first one that we care about is progressive, the big P in PWA. And that means that not all browsers are created equally, and they can't necessarily all do the same things. So progressive web apps are expected to gracefully degrade or gracefully enhance, depending on what the capabilities of the browser are, okay? Connectivity independent. Like I said, we expect the browser connection to be reliable. If we drop 3G suddenly for a couple seconds, or somebody reboots the Office router, we expect the page not to fundamentally collapse in on itself, right? To carry on working. We expect them to be app-like, and I know that's debatable, but we expect them to have an engaging tactile sense to them, right? We want to touch the page, the same as we would with a native application. We expect them to be fresh. Now, this is not something that's as much in the web space. In the web space, content is very, very current and fresh. But if you think about this convergence between web and mobile, freshness from a mobile perspective is a big deal, making sure that your app is constantly up to date and constantly got the latest information on it. So there is a part of that that's really important. And then the last part is making sure that it surfaces where the user wants to see the application, to treat it differently, right? And that's having the app be installable on your home screen, installable on whatever device it is that you're using. All right, cool. So how do we accomplish those things? Well, there are three big technological bits and pieces that we're going to talk about, right? And the first one is the app manifest. And this is really the lowest of low-hanging fruit. It's basically just a JSON file that says this is what my app's called. This is what it should behave like when it's outside of the browser Chrome. This is what the icon should be. These are the colors, so on and so forth. So it's pretty easy to do. And it basically is the thing that lets your app be discoverable and installable by the browser and OS around it. The second part is more a design pattern and aesthetic, right? And that's building your web application to embrace an app shell model, which is separating the content from the Chrome and seeing it as this immediately installable thing that is hydrated with content over time. Okay? And that is a broad spectrum, but it is an aesthetic that comes from a native sense. Like Facebook app on your phone, when you open it immediately, right, it's got those gray areas where the posts appear and they animate, and then only when the data is loaded does it appear in the application. That kind of thing. And then the last point is the service worker. Now, with any sort of like hype-driven movement, of which progressive web apps are definitely guilty, there is typically one or two fulcrum pieces of technology that it all pivots around, right? And service worker is definitely that thing. Now, the service worker is a JavaScript background worker that has network access. So the net result is that it acts like a secondary thread to your single-threaded JavaScript main thread that can behave like a reverse network proxy to the rest of the world. Okay? And the amazing thing about that is because it's got network access and it intercepts all of the traffic coming on the fetch API from the front end, from the main thread, you can do very creative caching solutions. And this is what enables us to have offline functionality. Okay, does it make sense? Great. So how are we going to, what are we actually going to use? How are we going to achieve this? So firstly, we're going to use a simple React application that I've created using create React app. Okay? We're not going to go too deep in the React side of things, although we can definitely answer some questions if there are any, and please feel free to put up your hand and ask them. Okay? But we use create React app. It's a very, very good scaffolding for building React applications, and it actually comes with a whole bunch of service worker stuff baked in under the hood. It actually uses Workbox, which is the library we're going to use. The problem is that they've got very opinionated defaults. So firstly, they disable service worker by default, and then secondly, they only enable a very limited amount of Workbox functionality as a part of the Webpack build tool. So we're not going to worry about all of that. Oh, wait, damn it, wrong button. That was not the button I meant to push. Okay, back. We're going to use Workbox directly. So I'm a big fan of the Unix philosophy, right? Lots of dedicated small tools, and we're going to use the Workbox CLI, and we're going to use that to build out this custom service worker that's going to give us all of that offline functionality. Now, lastly, and something we're going to dig into, is we're going to use Chrome, and specifically we're going to use the Chrome audit functionality as a part of DevTools, which is basically the former Lighthouse tooling. Okay, has anybody ever opened that stuff before? Okay, awesome. So we're going to take a look at some of it, and that's going to guide us through this journey of, well, what are we going to do to build a PWA, right? So where do we actually start? Now, my team is really lucky in the fact that we speak a lot into community. And because we speak a lot into community, we build a lot of presentations, and our presentations invariably have a lot of memes in them. Okay? So we decided to build our own meme generator. So we're going to start, oops, that's not what I wanted to do. That was not the button. What was full screen? Full screen. I don't want emojis, no! This is going awfully. Okay, forgot that command. Okay, cool. So here we've got a simple meme generator, right, that I've created before. I believe firmly that there's a Lord of the Rings meme that's appropriate for any possible situation in life. Jerry is about a 50-50 split between Star Wars and corgis, and Rory is all about Ron Swanson all of the time. Okay, so we've got this simple meme generator that then lets us create a meme. Is this going to work? And then it'll just create that, and you can save the image offline. And it just uses Canvas under the hood, right? So we're going to take this, and we're going to turn this into a PWA. So where we start is we start off by looking at the Lighthouse audit report. Oopsie. And the Lighthouse audit report basically gives us the score, which is not awful, but considering it's a really small application, it's not great, right? So we get an 89% performance score, and then we get 50% for progressive web apps. And now, I think the critical aspect of it is when we take a look at the metrics we care about from a performance perspective, our first contentful paint is sitting at about 3 to 3.2 seconds, okay, which is not great. So if we dig through this Lighthouse report, which you can run in a little while. Let's actually run it now. Let's go off script. What's the worst that could happen? Hey. I mean, it's already gone badly. So audits, run it. For those of you that have never seen a Lighthouse report. So what we do is we drill through all of the recommendations or opportunities. Okay. So long story short, that one didn't work. I don't know why. I'm not going to debug it now. And if we dig through all of the opportunities that it gives us, we can find a whole bunch of things that we can do to make our website, traditional React website, more progressive web app-like. So the first thing we're going to do is we're going to create an app manifest. We're going to create an app shell thereafter. We're going to pre-cache all of those assets, the static stuff that we were loading up in the application. And then we're going to runtime dynamically cache all of the images and data that it's accessing. The last thing we're going to do is we've got some UX around updating the service worker appropriately. Right. So this is going to be a bunch of live coding. It's going to happen really, really quickly. I'm probably going to make some mistakes, and we're all in this together, right? So you've got to shout at me when I do something wrong. Okay. So if we start off, and I'm not going to dig into this too much, we've got a very simple React application, which has a whole bunch of components that you could see built on the front end. And those are all sitting in the source folder. I'm sure you're mostly familiar with React, right? And we're going to touch this very, very little. Where we're going to start is in this public folder, right? Because the public folder is the thing that you put all of the static assets that are going to be bundled as a part of the application. And it's in here that we're going to put the manifest, because the manifest is basically a static file. Manifest.json. Okay. And I'm just going to smash in a whole bunch of JSON here that has, for example, the short name that's going to appear on when you install the app to your home screen. We're going to have the long full name that's going to be in the title bar, a whole bunch of icons that are quite honestly generated. I didn't code that stuff myself. And then stuff like the start URL and theme colors and so on and so forth. So it's some really, really simple basic stuff. And how we reference this thing is in the index.html, which sits next to it. We go into the head section, and we use a link rel manifest that links to the manifest.json file. And that's basically it. And if we reload this page, the exact one that should still be running isn't running. Man. It would have helped if it was started, right? Okay. We'll try running that Lighthouse report again. Now we can see in this application tab in the Chrome DevTools, we can see that there's a manifest.json with all of the details we've just provided, including our awesome meme images. Okay. I'm just quickly going to segue and run the audit report again so that you can see what it looks like so we can compare it with later. So basically, it just takes the initial start time of your application across a whole bunch of network conditions. Now, that is already not going to match with the stuff that I generated earlier because I've added the manifest.json. Okay, you can see there's a 3.2 seconds, and it gives you this whole list of opportunities of stuff that you can do to fix it. Okay, right, so back on script. That didn't hurt too much. Now, when we load this application, and let's just close this stuff. Okay, when we load this application, you'll see that there is that very typical ugly white flash, right? As the application is waiting for everything to come down the network, parse, and then before it can start laying out the bits and pieces on the page. JavaScript to boot, because all of the actual application is sitting inside React, so React has to start up. But we can fool that to give the user the sense of this application shell just by writing stuff directly inlined into the index.html. Okay, and we keep this really, really minimal. But the nice thing is that there's the side effect of this div that React bootstraps into, that anything we put in here gets overwritten. So in this context, you can see when I reload it, there's going to be a flash of the text in the top right corner. Can you see that? Okay. So what we're going to do is we're going to create, what number was it? 3, yep. we're going to create a little bit of prototypal HTML that's throwaway, right? Really minimal. That's going to be this app shell with a title, which is the title bar, and 3 memes underneath it. And we're going to complement that with a very minimal amount of CSS, just so that we can get the application sort of looking like where everything's going to be in case we've got some lag on the network, right? So the user at least gets a better experience than the plain white screen, and they're convinced that stuff's happening. So when we refresh now, you'll see that it has the placeholder of the bits and pieces that are on the page as it loads in. Now, this particular demo is far more impressive in Angular because Angular is a lot slower to start up, right? React is just too fast. Okay. It's not the last of my Angular bashing today. Okay, so there's that. So great. Now we've ticked 2 of the lowest of low-hanging fruit. So that's been pretty easy. Now we're going to get into some of the service worker stuff. And all of the service worker stuff that we've got, and I'm just going to yarn build because I'm going to need that in a moment, is going to hinge off of the Workbox CLI. So how you would install the Workbox CLI is by going npm install -g, so it's global, and then Workbox CLI, which I've already done, so I don't have to do it now. And then you can just use it by calling Workbox and then whatever. So I'm going to start off with the best name command ever, which is Workbox Wizard. Okay? And Workbox Wizard is going to prompt you with a whole bunch of stuff to try and set up your service worker at the outset. Okay? So it's going to say, well, which folder are you deploying? And now I know that in React, because I've now, or create React app, because I've built the application, I've got this build folder that's all my compiled assets, right? So inside that build folder, it's that one. I'm just going to select it and smash enter. Let's zoom in a little bit. Sorry. It's then going to prompt me which file types I'd like to pre-cache, and I'm going to just leave it as the default, which is to select all of them, and hit enter. It's then going to ask me where would I like to save my service worker, and it's going to prompt me with putting it in the root of the build folder, which is what's going to be deployed, and that's completely fine. That's typical. I'm just going to leave it there. And then the last thing it's going to say is, well, where would you like to save these options? And I'm just going to save it in the root of my application, because that's, again, very typical. So just with the defaults, I get a configuration that works for pre-caching all of the static stuff that React has compiled. It then spits out this generate SW method, which I'm just going to copy, paste, and run. And it's going to have, and just to scroll to the top of the screen, it's going to have some output here that says 18 files will be pre-cached, totaling about a half a meg. Okay? Now, what does that mean? That means if we firstly take a look at our Workbox config that's been created here, it's got all of those options that we've generated, which is our glob directory, which is what we're going to deploy, all the things that it needs to look for in a little bit of regex, and then where to put that service worker. And if we take a look at that service worker, there's a whole bunch of stuff here. So some comments. We can see that it's downloading the actual Workbox runtime scripts from a CDN, which is sometimes less than ideal, particularly for us in South Africa, right? We don't have any CDNs close by. Don't bring your AWS stuff here. Okay, let's keep it civil. Then it's got this method called precache manifest, and that precache manifest has basically hashes generated for versioning each of the individual files. Then at the end, it suppresses warnings, which should immediately make us feel comfortable, right? That was a joke. You can laugh. It's fine. And then it precaches and routes all of that stuff. Okay. Which is just to say that as soon as the service worker boots, it's going to go and fetch all of those resources immediately, so the browser page doesn't have to, and then keep it in a local cache. Now, this is great, and it was relatively easy, and the Create React App stuff, once you switch on the switch, is going to basically do this using Webpack under the hood, and you never have to care. And in fact, you can see one that was generated earlier by Create React App itself, okay, which is very similar. But we're not going to do that, because I like pulling the levers by hand, right? And it gives us a lot more flexibility to do creative stuff with the dynamic routing. So what I'm going to do is I'm going to create a templated service worker, and I'm going to put it in my source file or source folder because it is code that I care about. So in here I'm going to create an sw.js, okay, and save that, and I'm going to generate a little bit of code that's very simple to the bare bones cut down stuff that we've just looked at. So firstly, I'm going to source Workbox from a local rather than from a CDN. And then for its lazy loaded scripts, I'm also going to set the config that says, I want you to find all of your dependent submodules inside the local file rather than off of a CDN. Then we've got this variable that we're calling precache manifest. That's just an array that we want to smash all of those object hashes onto. We're going to suppress warnings because if it's good enough for Google, it's good enough for us. And then the last thing we're going to do is call precache and root. Now, to get this thing to actually work, we need to change some stuff. So in our workbox config, we need to add an additional 2 methods. Okay? We need to add an SW source, which is where we're going to find the service worker template, and then we have to give it an injection point regex, right? Which is this regex incantation which says this is where, and inside this capture group, you see those brackets over there? That's where we're going to put all of the pre-cached files that we've picked up out of your folder. Okay. Now, that's all great, and that's going to link together pretty well. But then after that, we need to install the service worker into the actual page. Now, there's a couple options for you here, and you can see that here after the React DOM render, so the initial touch point where React boots up, you can continue off that promise, and you can write some code here to register or unregister your service worker, and that will happen fine, right? And in fact, you'll see that comment that Create React App has that says this is where they recommend doing it. But another thing that you can do, which makes a whole bunch of sense, is putting it inside the index.html so that it boots up as early as possible, so before the React stuff has paused and run. Okay. So I'm just going to, for expedience sake, smash it at the body at the bottom here. All right, stop me if you have any questions. Now, service workers, because they really aggressively cache, have no place at dev time because your dev files are changing all of the time in thrashing. They only matter for production. So one of the nice things about Create React App is that you get access to the process.env stuff, and you can put your own environment variables and settings and things when you're building, so you can build for multiple environments. And by default, this syntax is what you use to pick out those variables. So in this case, I'm just going to use the default node environment, which is either development or production, okay? And just to check to see whether we are on a production build or something that's not, started up using Create React App itself. So when I check is production, then we're going to progressively enhance. If service worker exists on Navigator and we're going to pick it, then we're going to register that service worker.javascript file. This is relatively simplistic, and in real world, this can get quite a bit more complicated. But for sake of clarity, we decided to keep it brief. Okay, and that should be all. If my notes match, yep, that should be all that I need to do. Now, because I changed the index.html, I need to go and rebuild. So you're on build, rebuild that React application, and then after that's done, I need to do a bunch of things. So the first thing is I'm sourcing the Workbox libraries locally rather than via the CDN. So I have to go Workbox, copy library, if I can spell it, copy libraries, and I'm going to put that in the build directory. Then I need to run a command called Workbox inject manifest, and that's going to use the Workbox config. And then I'm going to use a simple NPM or node-based web server called HTTP server, and it's going to run the build directory. And because I don't want any server-side caching, so that I can test the caching in the browser and I don't get fooled by something, I'm going to disable server-side caching on this thing. But now that's quite a lot to run, so I'm not going to type that every single time. That would be boring. Instead, I'm going to go to my npm or my package.json here and add another npm script, which is going to be, is it 8? It is. Which is going to do all of that stuff for me, and it's just called start SW. So when I call start SW, just know that it's doing those things additionally. So now if I go yarn start SW, it's going to start up that web server. And now that I've got a service worker, I'm not going to do it in this window anymore. I'm now going to do it in incognito mode to make sure that I've got a clean environment when I start up. Okay. So now if I go localhost 8080 and everything works, there is our application. And we can see that in the service worker tab, there is this sw.js that is activated and running for the page. And we can see the source code there. It's exactly our templated service worker, and all of the manifest stuff has been smashed in. Okay, cool. So that's great. And if we refresh this page, we can see that all of the static assets, the JavaScript and stuff that's included as a part of the build process, is served from service worker rather than from network, okay, which is quite cool. So that's stuff that we've now offloaded, and as long as I use this site, it'll never need to fetch that stuff again, okay, or until it changes and the file hash changes. Right, so that's great, but now we want to also cache all of the data that's accessed in the page, these images, that JSON data, and so on and so forth. And we've now got the mechanism behind which to do it. So let's stop this, go into our sw.js file, and we're going to register some runtime routes, okay? And those routes use this workbox.routing module, okay? And they have 3 constituent parts. So the first part is a regex that matches against the URL, either in its completeness or a part of it, which makes a whole bunch of sense, to make sure that it's hitting the right URL point. Then we use a strategy, and that strategy is one of 3 things. It's either cache first, so hitting the cache first before going to network, then hitting the network first, and if you can't hit the network, go to cache, and then doing something called stale while revalidate, where you hit the cache, return it, and then go fetch from the network, and then update the cache. So your cache is always just one behind. So in this sense, we're going to use cache first, because the categories don't change very often. We pass it in config, which is just going to be which cache to save this into. And then the last thing we do is we specify which HTTP verb it needs to check against the URL. So get, post, put, options, whatever. All right. So in this case, we use get because get is one of the few cacheable in those. And we're going to do this for all of our data routes, right? So we're going to do it for our template data as well as for our memes. Now for our memes, there's something different, right? Because we fetch memes separately depending on which page you're on and which category you've selected. So memes has this very REST-like suffix, which is either LOTR or SW for Star Wars or whatever the case may be, which we wildcard out in the regex like that. We're using because it changes quite frequently, we're using the stale while revalidate strategy, which is going to make sure that it's always updated every time you request it. And we're going to put it in the same cache. Now, before we can test this, we also need to just cache the images. And the images is the exact same registering of a route, except we're just going to cache based off of suffix. Okay? And they're just image suffixes. We're going to use the cache first strategy, but we're going to put it in the meme images cache. Okay. Now, if I just run yarn start SW again, it's going to regenerate that service worker. And if we go to the application, and I'm going to leave the application tab open while I refresh, if you watch the panel on your right and you reload, you'll see that it installs a service worker, and it's now stuck waiting to activate. Okay? Now, what does that mean? Now, it's important to remember that the service worker acts like a network proxy, right? So there are browser tabs that are actively busy using it. So if we installed and overwrote that service worker that was actually running, we could interrupt some network traffic and lead to some unexpected behavior. And even if we do now push the skip waiting button and YOLO force in that service worker, we've now got stale content on the front end, right? And we've got a new service worker. So we have to refresh this to be able to get the latest stuff. And once we do that and we look at the network panel, we can see that all of the data and the images are technically being served from service worker, and the service worker is going and fetching those under the hood. So if I clear this and I navigate around, you'll see that the service worker delivers all of the bits and pieces. Okay. And after I go through the application, if I switch it offline now, I can still carry on navigating, and even though the service worker fetch fails, it still delivers the cached content, right? Which is pretty cool. And you can reload and everything, and it works. So it's fully offline, and it's not a lot of work to do it. If we go back to our application tab and we look in this cache storage section down here, you'll see that there's a bunch. So firstly, there's a phantom pre-cache cache storage thing, which I still haven't figured out, but hey, whatever. Then there's actually all of the statically cached files, and this is where Workbox is sourcing them from. Then we've got our meme data, so you can see all of the individual JSON bits and pieces that we've runtime cached. And then we've got our images. Okay, and we'll show a picture of a corgi. Corgi down. Okay. So that's where all that stuff is, and you can trash it out of here, and you can interact with it, and you can see how much size it takes up for debugging purposes. Now, that's great, and those are all fantastic, but we've got this weird skip waiting thing, right, that we had to do manually, which is not something we can expect our users to take care of. Okay? And if you don't do anything, you could end up with a website that basically never updates, or updates unreliably. Technically, if the service worker is shut down because all of the browser tabs and browser have been closed and then it boots up again, it should update, but that's somewhat unreliable behavior, right? So instead, what we're going to do is we're going to automate that stuff. Richard's going to correct me if I say anything that's wrong, right? Okay. Is it this one? It's that one. Okay. So the service worker, and you'll see that there's this self method, or self property in this file. And that self is a service worker standard thing that refers to the instance of the service worker. Now, it's got this lifecycle event called install that gets fired whenever the service worker gets installed into the page. And here we can automate the skip waiting and basically just bypass the need for the user to click the thing. But the page content is still going to be stale. It's going to have the same problem that we had previously, right? So we need to do a little bit more to refresh that content. So one of the patterns we use is we use something called the broadcast channel. Okay, who's ever done some pub/sub before? Anyone? Okay, so the broadcast channel is basically a pub/sub feature that lets you have a pub/sub channel between all of the browser tabs and web workers that are accessing this service-worker-channel. Important caveat at this point in time that this isn't supported in all browsers yet. It's supported in, I think it's Safari, Edge, and Chrome. Firefox is still lagging, I think. But they are, coming in Workbox, they're bringing polyfills to make sure that there are graceful ways to degrade that. Okay, so it's not a train smash. You can still have this UX. But just understand if you go and try this at home. Now, we've got this channel that we then create that we're going to share, and we post a message to it, which is just arbitrary data, where we tell the user that, or the other channels that we want to prompt to reload. Okay? Now, where we're going to listen to this is immediately after we've registered our service worker. So this thing is a promise, and it lets us continue afterwards. And as a part of that continuation, we can now do the following. We can create the exact same broadcast channel, so share the same name and subscribe to it. And then on message, for each message that comes in, we're going to check to see whether the data property has prompt to reload on it. Okay? If it does, you can then have either a nice toast or a modal pop-up or something, some UI artifact that's going to tell the user, hey, I've got updates available, I'm offline cacheable, would you like to reload the page? And put the ball in their court, right? Let them make the decision responsibly. Now, that was too much work for me, so I'm using this amazing baked-in piece of UI that you may have heard of before called confirm, which is basically just a pop-up that says, OK, cancel. Tough crowd, man. Anyway, OK, so we're just going to use the baked-in confirm functionality, and then if the confirm is successful, so they smash on OK, we're going to call channel.postMessage again, and we're going to send through a message that says skip waiting. Now, jumping back to the service worker, in here, we are going to, on that channel, respond to skip waiting by, again, listening to messages. And we're going to see, for any messages that have the skip waiting attribute set on it, we're just going to automate self.skipWaiting. Okay. And the reason why we have to check this stuff is because remember that both sides are now getting all messages, and all of these subscribers might be getting multiple messages going around. Now, again, we've just gotten ourselves to the exact same point that we were previously, right? Where we're skip waiting, but the front end isn't aware of it. So the front end needs to reload. Luckily, there's additional lifecycle events that we can use on the front end, which is in here. Let me put it in the right place. On service worker, we can add an event listener listening to controller change. So when the service worker that's underneath the browser tab changes, we can respond to that. And in that case, we're going to say, well, cool, something's changed, so I'm just going to reload this page. Okay? Now, if all goes well, come on, demo gods, hear my plea. Am I offline? Jerry, you rock. Yarn build. Okay, so we're going to build that. I've changed the index.html, which is why I have to rebuild all my assets. Okay, then I'm going to call yarn start SW. All right, which is going to start the dev server. Now, when I reload this page, because it's still running the old front-end code, it's going to stay stuck at waiting to activate. Okay, so I'm going to need to skip waiting to get the fresh service worker in, and then reload, and now it's all up to date, which doesn't help me very much. But now if I make, because this checks, the service worker install checks for byte exactness when it downloads the fresh service worker. So if I just make a white space change, like, cool, at the bottom, and I rebuild, we'll now see, when I reload this page and access it, on the right-hand side, we'll see the service worker is installing, activate and running, and prompting us to reload. Why is it activate and running? It should have stuck. What did I stuff up? Oh, no, that's right. That's exactly right. And then prompts us to update and then reloads the page on that. So it's a little bit clunky there, and it didn't work exactly as expected. Let's just do that again. Oh, they were. Is there? Was I offline? No. Open request was blocked and timed out. Oh, that would be why. Why is that? Okay. I've made a mistake somewhere. Is this in the... Oh. Brackets, man. I'm going to give this one last shot, and then I'm going to skip right past it. Okay, yarn start SW. Okay, let's just get the fresh service worker in here. Okay, sure. Okay, well, you could see it there. Let's just make that white space change just to be absolutely certain. Hey, I'm at least honest. Okay, now when we reload the page, you can see it's installing. No, it's supposed to be waiting. What have I done wrong? Anyway, it's the last attempt I'm going to have at that. But it's supposed to treat the user as king, right? And let the user make all the decisions as to what's happening on their own application. And it changes the way that people interact with it. So skipping past that fail. Actually, let's just go. No, not that one. Yeah, it wasn't as glamorous as this. I think I tripped a little bit at the end there on the last jump, so that's fine. So what's the net result? And I'll show you this in the actual audit logs in a second. We started off with those performance characteristics, and if we run the after performance characteristics, we can see that firstly we get a full marks for the actual performance measuring of the application, which is sort of expected because it's a tiny little app, right? And the progressive web appiness is increased markedly, and I'll talk about the bits and pieces of what we can do additionally to fill up the rest of that eight marks there. And importantly, one of the critical metrics is that we went to first contentful paint of 1.6 seconds, something that we can improve even further with some more changes. So if you look at what we need to do from here on out to fix it, is firstly they're big images, right? So that the memes look pretty. So we could probably use some kind of progressive images and progressively scale those up, or use newer image formats, and that's one of the things that the audit logs spit out. We can use text compression, which is an easy one because HTTP server doesn't have any text compression baked into it, and when we deploy to an actual server, we'll have static and dynamic content compression enabled. We can use H2 push, which will allow us to deliver a whole bunch more content better and faster. And one of the things that's failing behind the progressive web app score is that on local, I'm not running as an SSL-enabled website. And it knocks us for a whole bunch of points for that because we should be running SSL, right? We're all running SSL websites in production, right? Right? Okay. And then the last one, there's a whole bunch of code, like the whole new stuff, and potentially if this is a bigger application, all of the other pages that sit behind that first front page. You don't need to load all that JavaScript up to serve the site initially, right? So we can use some more creative code splitting techniques to build lots of JavaScript bundles and then dynamically load them on demand, okay? Which is not really hard to do. And if you use React Router, I think it's got very good support for that baked in. Very little work. Okay, so in summary, why should you care? Now, if you do not care about the performance narrative and making sites much, much faster over the wire and much, much faster in page, and you don't care about the offline and installable narrative where users can treat their web application like a native app, then I think you might be at the wrong talk. And I'm really sorry for having wasted the last 45 minutes. So I think this speaks for itself, and it definitely is the future of the web. You don't have to use all of these features, but some of the stuff is definitely going to make it into your space over time. Is this ready? Now, I can relatively confidently say yes, it's somewhat ready. It is ready. Service Work is supported in all of those evergreen browsers, with some idiosyncrasies amongst them, primarily on the Safari side, but everyone's very actively working on it, and I think a lot of this is going to be paved over come the next major releases of all of those platforms. So there's no reason for you to not start doing it today and then progressively enhance anyway. And if you cover those 4 browsers, including Edge, not IE11, that's Edge, okay? That's basically like high 98% of all browser access out there. So really, let's let IE11 die now. So finally, are there any questions? Yes?
I would like to know how do you get around the issue of storage, because caching all this data locally, and let's say for example, you now streaming content like video.
Yeah.
How do you get around that issue? Because I'm sure you can.
Sure. So you have to be very, very careful. The browser has baked in heuristics, and let me actually show you that quickly. I'm just going to open up DevTools again. Localhost. 8080. Yes, okay. You shouldn't have prompted there. Something's sick there. So the browser has inside, I think it's here, it has heuristics whereby it'll say, like, this site is given 98 megs of storage data, right? And if I try and exceed that, it's going to tell me, no, you can't cache anymore. So you need to respect the fact that you've got very limited real estate on the user's machine correctly, right? And for example's sake, if there were a lot more meme images, we'd want to like keep the last 50, right, or the 50 most recent. And there are plugins that you can put in Workbox that I didn't add, that you can, for example, say, go plugins, is it here? Yeah, it is here. Plugins, and then there's an expiry plugin. What's it called? Workbox? Workbox.plugins.expiry. Or something along those lines. I can't remember the exact verbiage, but that lets you, for example, say number of items, as well as size, and as well as how long you want to cache stuff for. So you can say, well, I want to cache things for a very short duration, just so that the website behaves quickly. Or you can say, I just want to cache the last 50 items in here, so the last 50 things as a part of it. Okay. So does that answer your question?
Yeah, it does, but I have a follow-up question. So does that mean you as a developer have control over the restriction or the size?
Yeah. I think it's an interesting question. You definitely have control, and you've got some restrictions that you've got to adhere to. The user, I think, can tweak some of those settings, but I'm not sure where. And if you're out of disk space, you're out of disk space, right? Yep.
The last time I was playing with these PWAs, I was playing around with the Bluetooth, like being able to access Bluetooth and that. Is that now available on iOS yet?
I think you should wait for the next talk to ask that question. Because luckily the next lady is going to talk to you all about web Bluetooth and what is and is not available. And I think the long and short of it is no, it's not. But there's a whole... One day. No, it is. It's on the implementation path, so it will happen at some point in time. Any other questions, comments, rude gestures? Okay, cool. Well, thank you very much.